Hi friends, welcome to Unacademy. Myself Bhavani. Unacademy Karnataka CET students who want to write a CET exam in the year 2021 can subscribe the plus courses. We have different plans, 12 months plan at the rate of 12,375. We also have a 6-month plan, 1,125. Whenever you join a particular use of the code Bhavani Live, student, this is a code which is going to give you the discount associated with this code. Join a plus class, you will have both class 11 and class 12 topics, and all the everyday paper. There will be full length mock tests, and also you will have quizzes for the analysis. There are different batches and also a number of educators who will be teaching the Unacademy classes. You have a comprehensive batch, you have a Kannada batch, as you can see here. So whichever batch is comfortable, you can join that batch. You can also join the Champions batch, which has begun from 15th of October. See to it that you are, joining this batch combination which you feel right, PCMB, PCB. Okay. Apart from that, you also have daily practice paper, this one free practice test. So in case if you are interested, kindly enroll your name for the practice test and try to answer as many as questions possible. You attempt test. Before that, you need to know the topic very well. When you prepare for a competitive level exam, student, knowing the concept becomes very much essential. Therefore, kindly see to all you are going with the concept very well. You are learning all, and then you are going ahead with the questions. Okay, and students, if you haven't question, kindly watch them. I have conducted, so you can go through it, and you can see to it that you are getting a benefit from all these tests. And also if you are liking it, kindly press the like button, and do not forget to share these videos among your friends, and also see to it that you are pressing the bell icon. That will give you the necessary notification related to my classes. Okay. So today, student, I'll be having one mock test on chemistry. So you can be ready now. I hope all the students who have joined, you are ready. So let us go with the question. An example of a protein which active material is option A, hemoglobin, option B, keratin, option C is albumin, and option D is oxytocin. So this question is from biomolecules chapter. So which protein will act as a structural material? Students, in case if you know the answer, kindly write it in the comment box. Some of you have written you cannot hear me. So can you hear me, student? Am I audible? Students, can you hear me? Am I audible, student? Okay, all right, thank you. So students, can you tell me what will be the answer for this? From biomolecules chapter, you have to pick a protein which act like a structural material. So what do you think is the right answer? What is the right answer, student? We know that keratin act as a structural material in hair, nails, etc., isn't it? We also have collagen and elastin. Collagen, elastin, these are all connective tissue, student. So these are also acting like a structural material. Therefore, the structural material which is present in hair, nails, etc. is keratin. Therefore, answer will be option B. All these are, factual. So once you know the topic, it becomes very easy to answer. Okay, we'll go to the next one. Which of the following is meta director? Option A, nitro group. Option B is aldehyde group. Option C is carboxylic acid group. And option D is all of these. So students, among the four options, which option will be the right one? Meta directors. Now you know that we have two kind of directing group. One is ortho and para directing group. Ortho para directors, one category, and the other one is meta directors. Now how do we identify ortho para directors? If the group attached to the ring is OH, suppose if you think it is OH, so in case if the group attached is OH, and student, if it is an atom which is attached to the ring is electronegative atom, under such case this is the one, and the atom which is attached to the benzene ring, if it contains a lone pair of electron, then it is ortho para director. How to identify for a competitive level exam? Easily. The atom which is attached to the benzene ring must possess a lone pair of electron. If it possesses a lone pair of electron, then it acts like ortho and para directors. If you have groups attached like this, now for example NO2, then the nitrogen here does not have a lone pair, isn't it? Now the electron pair will be shifted towards oxygen. This pi electron is shifted like this. That means electrons are withdrawn from the resonance. Such groups are meta-director. Meta-directing group. If you look at CHO, you know oxygen will pull. Once again the pi electrons are pulled. Carbon does not have a lone pair. It is withdrawing electron from the resonance. It is a meta-directing group. And if you have double bond OH, under this case also you see pi electrons are shifted, this pi electrons are withdrawn. So electrons are withdrawn from the resonance. When group, CHO group or COH group, all these groups are withdrawing electrons towards itself from the resonance. These are meta. Because of these group, we know that in ortho and para position is created. Therefore, the incoming group will come to the meta position. These are all meta-directing product. I told you the best way to identify when you see a lone pair, then it is ortho-para. Like this, with an electronegative atom, the electrons are pulled from the resonance, then it is meta-director. Therefore, answer is option D. Okay. Yeah, we will see whether we can include some questions from chemical equilibrium. Okay, for the next class. Okay, we will go to question number 13. Now this is a question from chemical equilibrium itself. 28 gram of nitrogen and 6 gram of hydrogen are mixed. At equilibrium, 17 gram ammonia was formed. The weights of nitrogen, hydrogen at equilibrium are respectively. You can see here 28 gram of nitrogen. 28 gram of nitrogen is nothing but 1 mole of nitrogen. You all are aware of it. 6 gram of hydrogen. 1 mole means 2 gram, isn't it? So when I say it is 3 moles of hydrogen, isn't it? 3 moles of hydrogen means 3 into 2, so 6 gram. So when you say 1 mole, it is 2 grams. So 3 mole means 6 gram. So 28 gram of nitrogen, that is 1 mole of nitrogen, is mixed with 3 mole of hydrogen. And you know, whenever nitrogen and hydrogen is mixed, you get ammonia. So if you balance the equation, you are getting 2NH3. So initially 1 mole is taken. This is the initial number of moles you are writing. And the initial number of moles is 1. Here it is 3, and you know you won't take the product at the beginning. Let us assume that at equilibrium, X is the degree of dissociation. X mole of nitrogen is reacting with the 3x mole of hydrogen to give 2x mole of ammonia. So what will be the number of moles remaining at equilibrium? Student, how much is remaining at equilibrium? Let us see. 1 minus x, 3 minus 3x and 2x. Now you can see here, it's given at equilibrium 17 gram of ammonia is formed. Now how much ammonia is formed? According to us, 2x. So 2x is equal to 17 gram of ammonia. Now if I say 17 gram of ammonia, it is nothing but 1 mole of ammonia. Do you agree, student? 1 mole is nothing but 17 gram. Why? NH3, so this will be 14 and this will be 3, so it will be 17 gram. That means X will be 0.5 mole. So you get 1 minus X, that is 1 minus 0.5, so remaining will be 0.5 mole. 3 minus 3 into 0.5, correct? So this will be 1.5. 3 minus 1.5 will be 1.5 mole. And this is 2 into 0.5, that is nothing but how much? 1 mole. Okay. Now we are interested in knowing the weights of nitrogen and hydrogen. Now what will be the weight of nitrogen? You know the number of moles. Number of moles. So when I say number of mole, 1.5, and what will be the weight of nitrogen? How much it will be? Is it 28? It is 28, right? Okay. So 1.5 into 28. So how much do you get? Or else half of it. Sorry, I need to write here. 1 second, student. Not 1.5. Okay, 0.5. 0.5 mole of nitrogen. How do you convert into gram now? 1 mole of nitrogen means how much? N2 means how much? 28. Half mole, 0.5 mole means 14 gram. So at equilibrium, the nitrogen is 14 gram. 1.5 mole of hydrogen. 1.5 mole of hydrogen means 1.5 and 1 mole of hydrogen means how much? 2 gram. That means it will be 3 gram of hydrogen. Therefore, weight of nitrogen and hydrogen are 14 and 3 gram. Therefore, the answer is option C. Okay, go to the next one, student. We'll go to the next one. I hope you have understood. Amount of heat evolved when 2 gram of sodium hydroxide is dissolved in 100 centimeter cube of 0.6 normal SCl at 298 Kelvin is. Students, when you are asking for a particular chapter, I have told you, you have to study that chapter and attend the class. When I will be taking my next class on 28th. So when I include those questions, you should prepare and come. Okay. Now the question is asked, what is the heat evolved when 2 gram of sodium hydroxide is dissolved in 100 centimeter cube of 0.6 normal SCl? So you have 100 centimeter cube of, the volume is this much and its normality is 0.6 normal. And to this you are adding 2 gram of sodium hydroxide. So what is the heat evolved? How do we find out? Now this can be converted to gram equivalent. How to convert into gram equivalent? Whenever the mass is given, formula for gram equivalent is W by E. Students, in case if mass is given and you want to convert into gram equivalent, then it is W by E. E is equivalent mass. W is given as 2. Equivalent mass of sodium hydroxide is 40. Why? Because sodium is 23, oxygen is 16, hydrogen is 1. 40. This is a molar mass. Molar mass divided by how many replaceable OH minus? How many are there? 1. That means its equivalent mass is also 40. So 2 by 40. Similarly, how do you convert? Now 2 by 40 means how much? 1 by 20. That will be 0.05 gram equivalent. Correct? Okay. Now this is reacting with this much SCl. We'll convert this also into gram equivalent. But this is not given in mass. It is given in volume. So what is the formula? Vn by 1000. And what is the volume? 100. What is the normality? 0.6 divided by 1000. Correct? So this will be, as you can see, 0.6 divided by 10. That means 0.06 gram equivalent. Okay. Both are not same. So whichever is the smaller one, you have to find heat liberated for that amount. Always remember, student, when a strong base, for example here sodium hydroxide, and a strong acid, that is HCl here, they react, 57.3 kilojoule of heat is liberated. This is constant, student. When a strong acid and a strong base react, 57.3 kilojoule of heat is liberated. Okay. So, when 1 gram equivalent of an acid react with a base, this is the amount of heat liberated. When 0.05 gram equivalent react, how much will be the heat liberated? So whenever strong acid and strong base is given, amount of heat liberated for 1 gram equivalent is 57.3. It is a constant. You should be aware of it. If both are coming same gram equivalent, then you will directly write. If one is small, other one is big, you have to write the heat liberated for the smaller value, smaller gram equivalent. So here 0.05 gram equivalent. So how much it will be? 0.05 into 57.3. So how much do you get? What will be the answer? Okay, so 3 point. You will get 2.86 kilojoule. Answer will be option C. Okay. Go to the next one. Which of the following will react with sodium metal? 2-pentyne, ether, ethane and 1-butane. We know that alkynes react with the sodium metal. Alkynes react with the sodium metal. Now why do they react with sodium metal? If they possess acidic hydrogen. For example, student, if I take ethane, ethane can react because this is an acidic hydrogen. Why it is acidic hydrogen? Look here student, CH triple bond CH. This is sp hybridized carbon, highly electronegative. So these electrons are more towards the carbon. That means this H can be lost easily as H plus. So this and this one both are acidic hydrogen. So they react with the sodium metal. Hydrogen gas is liberated and you get, as you know, sodium ethanide, isn't it? You will have CH triple bond C, Ne. Sodium ethanide is formed. That is what you have learned in class 11 under unsaturated hydrocarbon. That means our answer should be either 2-pentyne or 1-butane. You see student, 2-pentyne is like this. CH3 C CH2 CH3. Look here now, this will be 2-pentyne, but this does not have hydrogen at all. So there is no acidic hydrogen. We'll go for 1-butane. You have CH3 CH2 C triple bond CH. Students, here you can see, because it is on the terminal carbon atom, you have an acidic hydrogen. So this can react with the sodium metal, liberating hydrogen gas. Hydrogen gas will be liberated and you are going to get CH3 CH2 C triple bond Ne. Okay, CNE. So remember students, since it is triple bond at the mid carbon atoms, there are no acidic hydrogen present here. Therefore, 1-butane can react with the sodium metal. Have you understood students? Is it clear? Are you understanding? Okay. We'll go to the next question. Which one of the following does not undergo nucleophilic substitution? Student, either you can say does not undergo or undergoes with a difficulty among the four. Ethyl bromide, first one, allyl bromide, vinyl chloride and isopropyl chloride. So students, can you tell me among the four options which alkyl halide or aryl halide, which one undergoes nucleophilic substitution reaction? Which one? Ethyl bromide. Does it show nucleophilic substitution reaction? Yes. We all know that haloalkanes undergo nucleophilic substitution reaction, isn't it? It can show SN1 reaction or it can show SN2 reaction. We have studied about this one. We have studied the mechanism also, isn't it? Ethyl, one example if you want, ethyl bromide with aqueous potash. OH minus is the nucleophile, so OH minus will attack and this Br minus, that means you are going to get ethyl alcohol and KBr. And you studied the mechanism also. So ethyl bromide will undergo nucleophilic substitution reaction. Allyl chloride. What is allyl chloride? CH2 double bond CH2Cl. Student, this bond is broken. Therefore, you are going to get allyl carbocation. Allyl carbocation is formed. You know that this allyl carbocation can be resonance stabilized. So, allyl halides easily undergo nucleophilic substitution by SN1 mechanism. We will see the next one, vinyl chloride. CH2 double bond CHCl. You know that chlorine can exert plus M effect. The lone pair of electron which is on chlorine will migrate here and this pi electron shift because lone pair and the pi bond are in conjugation, so they will show resonance effect. So you are going to get CH2 plus single bond CH double bond Cl. No, CH2 minus, isn't it? Okay, pi electrons shift, you get a plus charge here. Now students, look here. If you see here, the bond between carbon and chlorine are double bond. It is difficult to break this bond and form a carbocation. So vinyl chlorides usually does not easily undergo nucleophilic substitution reaction because the double bond between carbon and chlorine, it is difficult to break, therefore they cannot form a carbocation. Isopropyl chloride also come under haloalkane. They also show nucleophilic substitution reaction. So the only possible answer is option C, that is vinyl chloride. Okay. Which of the following has a tetrahedral geometry? Now the coordination number will give us a clear picture about the geometry. So students, if we are trying also, we should try only with these two at the beginning. Because coordination number 4 means it might be either square planar or it might be tetrahedral. Now Cn minus is a strong ligand whereas Cl minus is a weak ligand. Therefore, here electron pairing does not take place. So, most probably NiCl4 minus is having a tetrahedral geometry. You can clarify it. The oxidation state is Ni2 plus here. So, electronic configuration will be 3d8. Nickel, it is 3d8 4s2. So, Ni2 plus means remove the 2 electron. You know there are 5 d orbital, 1, 2, 3, 4, 5, 3d8. So you have 1, 2, 3, 4, 5 and then you have 6 and 7 and 8. Students, because it's a weak ligand, the unpaired electron will not pair up. So in coordination compound, empty orbitals undergo hybridization, isn't it? So after 3D you have 4s and then you have 4p. So hybridization is sp3 and the structure will be tetrahedral. If it is NiCN42 minus, these electrons will pair. So you have one empty orbital, that is D, and one S, and the 2p orbital undergo dsp2 hybridization. So the structure, the geometry will be square planar, whereas this one is sp3 hybridization. So it is a tetrahedral geometry. So students, in case if you have liked my class, kindly do not forget to press the like button and also share these videos among your friends. My next class will be on 28th exactly at 2 o'clock. Okay, I will be including some of the questions from chemical equilibrium. So kindly join me, and in case if you haven't watched my previous YouTube session, watch them and try to solve as many as questions possible. So bye bye students and take care.